How do you think the sideways speed of an object affects how fast it falls? Does a ball thrown sideways fall at the same rate as a dropped ball? Discuss. Now watch this video. What do you observe? Newton figured out that without the influence of air, that all objects fall towards the center of Earth at the same rate, regardless of their mass. Also, regardless of how fast they're moving sideways. The curvature of Earth. Earth is round, so the ground 1,000 meters away is a little bit lower than the ground nearby, assuming no hills. The fired bullet has to fall a bit further to hit the ground. This got Newton thinking. What if a cannonball were fired so fast that it fell around Earth? He imagined firing a cannon sideways on a mountain at higher and higher speeds. He figured if he shot a ball fast enough, its fall would match the curvature of Earth, and it would keep going around. It would orbit Earth. The image on the next slide is from his book, published in 1687. You can read his words and see his diagram in this English edition. With this set of animations, you can see Newton's thought experiment come to life. He then did the calculations and showed that the moon was moving at the correct speed and height above Earth to be in orbit, just like the cannonball in his thought experiment. The moon keeps falling towards Earth, but it keeps missing. Its sideways velocity carries it around Earth. Without its sideways velocity, the moon would fall to Earth. In the same way, Earth falls towards the sun, but keeps missing because of its sideways velocity. Without that velocity, Earth would fall into the sun. So, why do you think that almost all the celestial objects we see are in orbit around another object? What would happen if they were not in orbit? Discuss. A dropped and fired bullet will hit the ground virtually at the same time. But there's one reason the fired bullet would stay in the air a tiny bit longer than the dropped bullet. Any ideas? Without its sideways velocity, the moon would fall to Earth. The moon wouldn't exist. Without its sideways velocity, Earth would fall into the sun, and Earth wouldn't exist. All masses are attracted to all other masses, so objects either orbit one another or they collide and disappear. So most everything we see in the universe is orbiting a larger mass.